So let's work at practice problem number 14 on page 133. And here it is in your book. Let me zoom in on it. It says, a boy exerts a 36 Newton horizontal force as he pulls a 52 Newton sled across a cement sidewalk at a constant speed. Constant speed. What is the coefficient of kinetic friction between the sidewalk and the metal sled runners? Ignore air resistance. So let's apply the procedure to that given. So here's our sidewalk. So here's our sled. Just draw like a little sled-like thing, like I don't know what a sled would look like, but something like this. And so here's our boy that's pulling on it. He's really putting his back into it, looks like. So anyway, he's pulling this sled, and the speed is constant. And we know the weight of the sled here is 52 newtons. And so, and what we want to find is the coefficient of friction, mu sub k. It's kinetic friction, that is, the two surfaces are sliding. Okay, does that make sense so far?
Yeah.
Okay. So, let's solve it. Well, first of all, I know that the force of friction is equal to mu times the normal force, right? This is an equation that we developed with the friction lab. It's just something that you should have in your equation list. Friction is equal to the coefficient of friction times the normal force. Okay? So this tells us what we need to know. If we want to find mu, well, then mu is going to be, just divide both sides by the normal force. Mu will be equal to the force of friction divided by the normal force. So this tells me what to do. I need to find the force of friction, and I need to find the normal force. Well, that means I need to use the procedure. So I'm going to draw the sled. I'm going to do step 2 of the procedure. I'm going to draw the sled. Here's just the sled, and I'm going to show here's my sled, and I'm going to show the forces acting on the sled by the outside environment. So we got this kid that's pulling on it with this applied force. And, oh, you know, one thing I forgot to mention, that this applied force was given to be 36 newtons. I forgot to put that in there. Okay. So then we've got the weight of the sled, which is also given. I've got the normal force. That is the interaction between this surface and the runners that's perpendicular to the surface of, and then I've got a force of friction, like that. So there's my free body diagram. And we'll identify our coordinate system. Here's our x and y axes, like that. So notice I'm following the procedure. I've got my free body diagram, this, step 2, step 3, step 4. Let's sum the forces in the x direction equals ma in the x direction. This is Newton's second law applied in the x direction. Well, if I look at this in the x direction, I say, well, I've got two forces. I've got this applied force, and I've got this force of friction. This is in the positive direction, so Fa minus the force of friction. And these are the only two forces. This is minus, right, because it's in the negative x direction, equals, well, what is the acceleration in the x direction?
It would be 0.
It would be 0, exactly, because my velocity is constant. It was given to be constant. So this is 0, which makes the whole thing 0. And all this says is, hey, my force of friction is going to be equal to my applied force. Well, that's going to be 36 newtons. So that's nice to know. Then if I sum the forces in the y direction equals ma in the y direction. Well, what forces are acting in the y direction? I've got this normal force in the positive y minus gravity equals, and what's the acceleration in the y direction for this sled?
It's 0.
It's 0, right? It's not flying up into the air. It's not sinking into the ground. So it's 0. And all that tells me, oh, my normal force is equal to the weight of the sled. But we know what that is. The weight of the sled is 52 newtons. That was given. So now I know the force of friction is 36, and I know the normal force is 52 newtons. I can solve the problem. Mu is equal to the force of friction, 36 newtons, divided by the normal force, 52 newtons. And I take out a calculator, 36 divided by 52, and I get 0.69. And there's no units. Well, you could put newtons per newton, which is perfectly legit, or you can say the newtons cancels the newtons, either way. So mu equals 0.69. And that's my answer. And that is practice problem 14.